两小不在，叫两小吧，两小，两小不在。要去考试吗？两小。哦，有在，我找到他了。你们今天下午还有补课？ Oh, you went to breakfast, so maybe you can start first. Hey everyone, welcome to the last lecture. So the plan for today is first hour we'll finish the last tutorial I posted on Moodle. If you already done it, you can go and do the review question. And then after half an hour, we will discuss run through the last tutorial. And then for the second hour, we'll summarize the content after the midterm, and then maybe give some hint on, on which part to focus for the exam. And then third hour, we will discuss the quiz. Anyone look at the tutorial question yet? Anyone look at the tutorial question? Try to discuss with your friend. Try to do at least one question from 1.4, the KMAP, so that when I discuss later, you won't get lost. Try to do at least one question from the KMAP, 1.4. I suppose. Think simplify. Try to do one KMF question. KMF will be a pain.
你们吃这样久吗？
Yeah, shall we discuss now? Shall we discuss? Yeah. 12.1.35 to 37. This is proving laws using the definition of Boolean algebra. Okay. So Boolean algebra only have 5 laws to satisfy. But remember that in the table we have almost like 10 identities, right? So how are the extra identity get proved? So this is to use the definition of Boolean algebra. So from the 5 laws, you can prove 5 or 6 laws. Okay. So what 12.1.35 is one of the examples. So you are asked to prove the idempotent law. Okay. X or X equal to X or X and X equal to X. Okay. So how how you go about with this? So the key here is to use the 0 and 1. Play with the identities. So identities in an algebra is very important. So you can play, you need to play around with the identities. So I start from X, okay, and then I introduce the additive identity. Okay. From there, I can create element using the complement of. And then from here, and then you can try and expand it using the distributive. Okay. And then you can see that one of the term gets simplified using the complement. And then you left with X or X. So from one X, you can create another X. And just using the identity 0, 1. Okay. So you need to play around with the zero. You need to introduce the right mode. Uh, yeah. I saw some of the students use the truth table. Okay, of course you can use truth, but the idea to introduce Boolean algebra is to see through the abstract algebra. And then 12.1.36 and 37 will be similar. Just play around with the definition of Boolean algebra. 12.3.2 and 46, 12.3 section. I think this one is a repetition from the propositional logic. Okay, so should be simple. The idea for this section is I want you to, whenever you see this expression here, okay, you should have a logic gate behind your mind. Okay? You should have this kind of picture behind you. Okay? When you're looking at this function here, there should be a logic gate behind you. Okay? And then the task of this section is to minimize it. Minimize the use. So when you see the function, you should have some logic gate, combination of logic gate behind your mind. Okay? And then you want to try and minimize it. Then this will lead to the next section, the K-map. K-map. So 12.4.2 asks you to build the K-map. Okay? How do you build the K-map? So for two variable, you have four blocks. Three variable, you have 2 to the power 3, 8 blocks. X cells. Again, and then four variable, you have 16 cells. So there are two variables here. You should build a 4 cell. Okay? And then how you put the one depend on what minterm you get. Okay? So if you have 3 minterms, you should have 3 ones. Okay? And then label the one in the right block. Okay? Make sense? So the first step to do K-map minimization, you have to know how to label your block first. Anyone have issue labeling the blocks? No? Yeah. Before we start doing minimization, you have to know how to label your block. How to build your cell. Okay. So you have to make sure the adjacent cell must differ in exactly one literal. Okay. So in 4 cells, 2 variable case, this one is easy. No matter how you put, they will be adjacent. But in the 3 variable case, this one is different already. Okay. So if you play it wrongly, then your K-map won't work. So for example, if you put y bar, so if you put y bar z bar here, then this one will be wrong. Can you see why? If you put the first column as yz, second column as y bar z bar, this one will be wrong. You know why? Huh? What? Yeah, so the adjacent cell must be only differ in exactly one literal. Okay? But this one differ in two literal. Okay? So you need to make sure the adjacent cell only differ in exactly one literal. One literal. Make sense? Huh? The what? Two line or the line? You want to close the line? Yeah. Okay, so this one is not allowed, okay? So you need to make sure it is adjacent. No matter what what minterm you start with. Okay, you also can start with YZ bar, but the next one should be Y bar, Z bar, or YZ. Okay. As long as they are adjacent, should be fine. So you can see that there's a different way to build this K-map, the table. Okay. So sometimes for some function, the block is easier to see for different K-map. Okay. Make sense? Yeah, the block will be different, correspond to different K-map. Sometimes some combination is easier to see. Yeah. Okay. Make sense? Yeah, because the one will move based on your labeling. Sometimes it's easier to see them. Okay. So the key to build the K-map is adjacent. Adjacent cell differ in one literal. Okay. Okay, next. Next to build to simplify the K-map minimization, you need to consider block of one that's in the form of product of the power of two. So for example, 1 times 1, 1 times 2, 2 times 1, 2 times 2, 4 times 1, 1 times 4, and so on. Okay. Product of power of 2. Okay. So so what? Okay, so this one we have go to last week. If you have x, y, x bar, y bar, you can form the block of 1 times 2, and then you can simplify it to just x bar, because you can see it from the algebra, right? So you can use distributive to pull out the x bar, and then y plus y bar is just 1. So x1 times 1 is x bar. Make sense? Okay, so when you see the block, you can reduce the literal, depend on the block. Depend on the horizontal block or depend on the vertical block. So you can see here, so here is a block of 4, here reduced to 1. But here also block of 4, but here reduced to Z bar. Okay, can you see the difference? This one will depend on how many variables you have. Okay, in this case here, you only have 2 variables. Okay, so you only include all the possibility. But here you haven't include all the possibility. You just partially. So you only can simplify 2 liters. Okay, so make sure you know what is going on. You can use algebra to show it. Okay, so one of your friends, oops, oh, not here. I got an example from last time. So he asked about this one. Show you. Okay. He said, how about this? Okay. How about this term here? So he said, I use algebra. I got x bar, y plus y bar plus xy bar, which is equal to x bar plus xy bar. Right. So how do I get x plus y bar here? Does it mean x equal to 1? Yeah. Right. No. Because what you can do that, what you can see from the map here, actually they overlap here. Okay. What this means for algebra is you can introduce an extra term. So you can add another x bar, y bar. Okay. So why can you do this? Why can you do this? The first thing we proved just now. What's the first thing we proved just now we discussed? Huh? What law? I idempotent law. Okay, so I introduce the same term. The same term plus the same term, you get the same. Okay, from here, you can go and do the simplification. See that? Plus. Okay. Then from here, I think should be straightforward from here. Can see or not? Okay. Understand? Can see it? Okay. Yeah, so there's some overlap there. Okay. So algebra and K-math should work together. But in the exam, I will ask you to use K-math. So you have to learn how to use K-math. Okay, algebra and K-math. Good. Okay, this one. Okay, this one. I think this question is important. This one. This question is about uh, the idea. Again, the idea of the whole section topics here. So the question asks, what are the implicant? What are the prime implicant? What are the essential prime implicant? So who are the implicant? Okay. As long as you have a one, okay. Okay. As long as you have a one cell with one, okay, it will be called an implicant. Okay. So for example, if you do like this is an implicant. This is also an implicant. This is also an implicant. Okay. Any block of one is an implicant. Any block of one is an implicant. Okay, maybe I give you an example. So x, y, z bar is an implicant. But x, y bar, z bar is not an implicant because there is no one here. Right? This is not implicant. So implicant depend on your function. So implicants defined for a function. Okay. So x bar, x, y bar, z bar is not an implicant because there's no one here. Then any block of one would be an implicant. Okay. But to do the K-map or the Queen-Minkowski method, QM method, we have to find the prime implicant. Okay. Why is it called prime implicant? Because it's like prime number. So all the number is a product. And now the function is a sum of the prime implicant. Okay. So what's the prime implicant? What's the definition of prime implicant? So the block of one which is not contained in another larger block. Okay. So you can see that the block of one cell, right, always contained in a larger block one times two. So a block of one cell is not a prime implicant, where all these 2 times 1 cells will be the prime implicant. Okay, because they are not contained in a larger cell. Okay, so these are the prime implicants. Okay. Makes sense or not? Just ask them. This is the last lecture already. How about essential? The definition of essential. The largest block of one that covering one in the KMAC. Okay. So the block is the largest block that covering the one in the KMAC. Okay. Covering a one in the KMAC. So for example here, okay. So this block here, okay. So how many one? Two. Okay. You can see that for this one here, it is covered by the other block. So this block is shared by different block. But this one here is only covered by this block here. So it is the largest block of one that covering a one in the KMAC. Okay. No matter which one, as long as there's one inside the block, it's not covered by the other. This will be called essential. Okay. So in this case, these three blocks here are essential. And because they have one that is not covered by the other block. Make sense? Okay. Yeah. So how about this? Let's look at this example here. Okay. I have 1, 2, 3, 4, 5 blocks here. Okay. So are these essential prime or not? Which are these essential prime? Are they the largest block of one that covering the one in the cabinet? Any essential prime? Which block is the essential prime? Block is the essential prime. Exact. Where's exact? Exact. 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 This one. This one. Is this the essential prime? Is this the largest block of one that covering one in the map? So this one is covered by the other block, and then this one is also covered by the other block. So it's not the largest one that covering the one in the cat. Okay. So you can see that actually for all these blocks, right, they are not essential. Okay. Because they are all the ones in the block are covered by the other block. Okay. For example, okay, let's come back to this question. See which one is essential. There are 1, 2, 3, 4 blocks. How many essential prime here? 2, okay, which is 1 and 2 is 2. Make sense? Okay. So yeah. So essential primes is easier to when you see essential prime, right? Okay. Usually these are the one you must have in your minimization. Okay? Because this is the only time you can meet the one in the camera. Make sense? Because if you don't pick that block right, then you will miss one of the one. Okay. So first, what you do in the minimization, you should pick all the essential prime first. Okay. For example, you should pick this one, you should pick this one first. Okay. So for this two, you can pick either one, right? To cover this one. Make sense? Make sense or not? Right. Okay. But for non-essential one, right? Okay, so you need to be a bit careful. Right? So from 5 of these, you need to pick the least number of one that cover the so enjoy I go. Why don't take away from all of them for the class?
Nah, got yours one.
No money.
Really go.
To take away from the class. Then we got class party. Class party. Okay. Okay. So yeah. So for non-essential one, you need to be careful. Okay. Use your description to check what is the least block to take. Okay. I haven't eat yet, so long. Okay. Um,
得我誒，入到處啊。
okay. Yeah. Okay. So because in the there's people ask that should we draw all the block? Okay, should we draw all the block? Okay, because you can see that there's non-essential one. So maybe I don't want to draw this block. Okay. So there's some risk on doing this because you might throw away the minimal solution. Okay, the least number. Okay. So for example, in this case here, what's the least number of picking all the one or uncovering all the one? What's the least number? Okay, so how you do? So you can do like this, and then do like this. Okay. But let's say if you remove, if you remove this guy, okay, you can never reach 3. Okay, if you remove that circle there, you will never reach 3. Okay, your best answer is 4. You never reach 3, so you will miss your answer. So make sure you draw all the possible block, okay? All the possible prime indicator. Okay, about what? The fourth? Yeah. Okay. Let me remove one more. Remove this guy. Remove this guy. Okay. Now the least number is 4. Okay. Yeah. Okay. Yeah. So you need to draw all the possible ways. Otherwise, if you miss, maybe you will miss the answer. Okay. Because this is the best answer you can get from this time. Okay. So if you introduce the vertical one, then you can reduce your. Okay. So the lesson here is you have to draw all the possible prime. Otherwise, you'll miss out the solution. Okay. So the next part is the QM method. Okay. So the QM method here is the presentation is different. Okay. Instead of drawing cell, we just label our midterm as 1 or 0. Okay. If it is X, we put 1. If it is X bar, we put 0. Okay. And then what you do is step-by-step simplification. Okay. You simplify adjacent cell in each step. Okay. So for example, 1 and 2, they are differ by 1 literal in Z. So you can simplify them. Okay. And then 1 and 3, You also can simplify them because they differ in y. Okay, and then you check it for all the possibility. Check 1 with all the possibility. Check 2 with all the possibility. Okay, 3 with all the possibility. And then when you simplify them, the term gets simplified, you put a dash. Okay, because if, for example, if 1 and 2 combine, z and z bar disappear. Okay, so you put a dash for your z, and then you do similarly for the other term. And then you combine again adjacent cell. So for example, xy and xy bar. Okay, so 1, 1, 1, 0, dash, dash. Okay, differ in one literal, so you become x. So you throw away y and z, become dash, dash. Okay, so you keep doing it until you can't do it anymore. Okay, so what does it mean by you can combine? Actually, these terms are not a prime implicant. Okay, so what you left with is the prime implicant. So you need to pick up the prime implicant. Make sense? Make sense? Okay. Okay. So if you can imagine in your mind, right? Try imagine your mind. So here we are like combined adjacent cell like this. Okay. But in this step here, we are combined all cell. So actually the term that you combined before are not the prime because they are contained in a larger block. What you left with in the end that's not used to combine will be the prime implicant. Okay? And then to find the solution for minimization circuit, you need the prime implicant. And then you need to build this table to record which term they cover. Okay. So why I put x, 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 x here? Because, for example, the x here, yeah, I mean the literal x, the literal x here cover 1, 2, 3, 4. So I put a cross at 1, 2, 3, 4. And then this z cover 1, 3, 5, 6. I put a cross at 1, 3, 5, 6. Okay. Yes. And then next you need to pick the smallest set of prime implicant that cover all the function. So for example, if I pick 1, I cover 1, 2, 3, 4. Okay. So I still need to cover 5, 6, 5, 6, 7. So I still need more min term to cover 5, 6, and 7. So for example, the Z will cover 5 and 6, and then Y bar will cover the 7. And so you need 3 of them. Make sense? Okay. So sometimes it's not the case. For example, this example here. Okay. So this example might have more way to do. Okay. So you have 1, 2, you have 9 terms here. You need to cover with. You have 9 min-term, 9 prime implicants to cover. Okay. So you need to pick the least number to cover the 9 term. Or do you want to try and pick or not? Or you want to pick? Okay. So let's say you want to cover this 9 term here. So which one you want to pick? Huh? Which prime implicant you want to pick first? Maybe YX, YWX. Huh? YWX first. Okay. Let's pick YWX first. Then you will cover 1 and 2 already, right? So what you need to cover, the rest is 3, 4, 5, 6, 7, and 9. Okay? So you need to find other prime implicant that cover this 7 term here. Okay, which one you want to pick next? W, Y bar, Z bar. Okay, this one. So you cover 3 and 6. Okay. You still have 4, 5, 7, 8, 9 to cover. So which one you want to pick? W, X bar. That's wait. Oh, the best one. Okay. So 4, 5. Okay, you still have 7, 8, 9. Huh? First one, huh? You see, first one is only covered by this. This is the essential prime. It only covered by W bar X Y bar Z. So you must pick this guy because this is the only block that contains the one here. Okay, how about 8 and 9? The last one, huh? Yeah, the last one. Okay. If you pick this, then you got extra already, right? Because W bar X bar Y already help you to cover X bar Y. So you got 1, 2, 3, 4, 5, 5. Huh? Okay, come out already. Yeah. Okay. So yeah. So in principle, you need to check whether why this 5 term is the least number or not. So see if you can find 4 midterms to cover. If you cannot, then it could be 5. Yeah, the answer is 5 also. No, it's different one. Okay. So you could have different answer. But you have to make sure it's the least number. So you need to check whether you can do it with 4 or not. If cannot, or 3 or not, 2 or not, 1 or not. All the number below 5, you need to make sure you cannot do it. Because too long.
Too long. So I just skip.
Yeah, too long.
Yeah.
Since I already labeled the midterms here, so I might as well just use the number. Otherwise, too long. Next. Yeah. But KMAT will definitely come up in the exam. Any question or not? No? Yeah. Understand the which one? Definition of implicant. Oh. Go through again. You mean just for implicants or prime implicants and central implicants? All these three. All these three, huh? All these three, then maybe we go. Okay. Okay, so the idea is these three ideas will be based on your K-map first. Okay. To build a K-map, maybe I draw the chart. So you can see that this definition here, okay, for implicant, the product of literal correspond to a block of all ones in the K-map is called an implicant of the function B mean y. So it depends on function. Okay, so you need to start with the function first. Okay. So given the function what is so given a function you can build a K-map, right? Okay, so give you a function, you should have a K-map in your mind. So what is an implicant? So implicant are product of literals correspond to a block of all ones. Okay, so for example, maybe in your mind you have xy plus x bar y bar. Okay, so you build a K-map. You get two ones here. Okay, xy and sy bar. Okay. So what kind of block of one you can draw here? What kind of block of 1 you can draw here? X, Y, and X, Y, Y block. Okay. And then from here, this block is what? X, Y, and X, Y, Y block. So these two are the implicants for the function. Okay.
What if we have another one in?
Okay, let's okay, good. Let's what if we have another one? So maybe we put SY bar in. Okay, we put SY bar in. Yeah. Okay. How many type of block we can draw here? Okay. Draw the 3 1 times 1 block. Okay. We also can draw 2 times 1 block. Okay. So there are 5 different implicants here. Yeah.
Write down the sequence of two, one.
Oh yeah. So you just simplify it, right? So this block will correspond to X, and then the other block, the vertical block, will correspond to Y bar. Y bar. So you just minimize that block. Yeah. Yeah, you can list out all the implicant, or you just describe the block. Block of 1 times 1 cell, or block of 2 times 1. Huh?
This keep the definition, right?
What? No. I mean, you mean how to describe the block, is it? Yeah. So describe the block. You can either tell the size of the block, or you just tell me the implicant. Tell me the implicant. You tell me the implicant, I will know how to find the block. You know what I mean? So for example, okay. So for example, I say that there's an implicant X here. Okay. So I will automatically go and find this block here. You know?
Just
Yeah, yeah. Right, what? Yeah, right the implicant term. Okay. Yeah, write the implicant term. Yeah, it's the easiest way. Write the implicant term is the easiest. Prime. Okay. So from just now, right? So among these 5 blocks, which one is prime? So prime is what? Recall the definition. This block of 1 is not contained in a larger block of 1, representing the product of fewer literals than this one. So,
Blue one.
yeah, so the blue one will be the prime implicant. Okay, because the green one is contained in a larger block of 1. Right? You can see it? So the green one is contained in the blue one. So the green one is not prime. But the blue one is not contained in the larger one, so it's prime. Okay. Essential. Okay. So what's essential? If this block of 1 is the only largest possible block of 1 covering at least one in the map. Okay, it's the largest one that covering at least one in the map. Okay, so since it is not prime, then the green one definitely not essential anymore. Okay, already not prime, so they are not essential.
It has to be prime to be essential.
That's why it's called the essential prime. Otherwise, it can be called essential implicant. Okay, so essential prime means it must be prime first and then essential. This is how they create this. Okay, yeah. Okay, so start from prime. You need to decide whether it is essential or not. Okay. So you need to ask this block of 1, is it the largest block of 1 that covering a 1 in the canal? So how many 1 the block cover in this case? There's only 2. Okay. So you need to ask whether the 1 inside the block is that is the only block that covers the 1. If it's not, then it's not essential. But if yes, then it is essential.
So in this case,
it
is
why it is?
another one is not covered in another.
Yeah, so there is a 1 that's only covered by this block. Although this 1 here is covered by the other block, but this 1 is not covered by the other block. That's all. Maybe we can simplify. Yeah.
What's the difference between prime and essential?
What's the prime and essential prime? Okay, so a prime can be not essential. Okay, a prime can be not essential if all the ones are covered by different block. And just now we have this example. So, for example, just now what's the example? Try. Yeah, something like this. Okay, so these are all prime, but they are not essential. Because all the block of 1, it is not the largest block that covering 1 again. Because in all the block, the 1 is covered by different block, can be covered by different. Yeah, so they are not essential 1. So they are not essential, you know, what is essential? If you don't have it, you will die 1. Yeah, a must. Okay. Right? If you don't have it, you cannot cover your function anymore. So that's how we call it essential. Okay. Yeah. If you don't have it, you cannot cover your function. Okay. But these are all not essential. Okay, because if you lose one of them, you still have another one to cover it. Okay. Okay. Any question? If more questions later, we move to next section. If you can ask, maybe we take a break until 10:41, and then we'll come back for some minutes.这保佑是呀，太搞笑了，对下先生。哦，对。剩下来是不是也是一样的？你就是用通过，但是问题是它的这个 definition 是 based on 这个。小。就是说，那如果非常，我们可以翻译过来，当然。
那如果你的意思说你是拿这一个去 build 你的 payment 哦，那肯定是啊，
肯定是啊，对，这个是。
再看这个，你要看这一个的样盘的内容。如果你看它
算一下，刚才我跟老师讲这两个是因为我讲一个是对筛选很错。
It's in the final.
But final has nothing to do with yeah, the answer. Pumping. Yes. Later we will run.
这种后教，这种有没有？哦，那个没对。
这个
中文名的看翻译的放的，
你看这个，它是这一个是一，然后看 OK 例子例子你看不懂，例子用例子来理解。那 bullying product of 这个东西，OK， 这是另外一个意思，product of S literal。什么是 literal？ 你要知道什么 ？literal 是一个 x 或者 x 八，很多叫什么？然后所以它就是它的组合 x 和 x 八的组合，我们叫等于分母。所以你讲这样的组法的回来，我们把 x 八这个 x 八 x y 八。X bar to Y bar 都是因为那种the product of n 项乘法 such that 一项是 x 一项是 h。知道，反正都不太定的。
我这个最常
没有特别意思的就存起来嘛。这个也是叫名分，这个也是叫名分。这是名分哦，没有，它就是一个乘法罢了。
我不会就
别的这边是，这边不是这个。
影响，
对，
查了这都是程序表象，然后中文这个课本是
这样，它就是一个基数嘛。你不要被这个影响，不要有先入。
这个管
本来就是这样，不是管那个是你管那个。他就是这样。
这个也是很少看。
变变的时候。你知道他在说什么？他是说这个名称呢，它只能够 evaluate 去 one 一种组合可以让它拿到一分，对吧？是不是这么说？比如说你这个组合要怎么拿到一？这个要一嘛，这个要一嘛，这个要零的。z 要等于零，那我们就说 z 就是一乘一乘一才能够拿到一。但是
这个算是一个那个什么？
这个是一个不连根的，对对对，不是，OK，有一个小差别在这边，就是他把这个 z 放进来，就是不列 expression 里面我们没有把，对，没有了，对 expression 我们只有这种东西，把 x y 啊但是我们不会放 z 这个8进来，所以我们才要有这种特别的名称。连 OK， 我们要怎样讲 ？OK， 因为到最后的时候，我们要拆分 z 和 z 嘛。OK，expression 没有拆分 z 和 z 嘛。expression 我们没有把这两个是不同的，在 literal 的时候我们还是不同的，对，但是他们 z 和 z 为什么要叫这个？
能理解。这个名称就是
这些组。不能 product， 对对对。
这叫哪个名字？
名称是哪里？不能 product。好，看这边啊。OK。Yes，这两个。
也是你想学的东西。Okay, okay, so let's recap what we did after midterm. Okay, so after midterm, the topic is counting. So in counting, we have product rules, sum rule, inclusion, exclusion, principle, pigeonhole principle, and permutation and combination. Okay. So inside permutation and combinations, we have binomial theorem. Okay. Make sure you know how to use binomial theorems. So there's a big question on binomial theorem. Okay, how to expand the binomials term. Okay, so you can take note of this. I think we also have done it in the tutorial. So make sure you know how to use it, how to play around with the binomial theorem. Okay, pigeonhole. I think there's no question on pigeonhole, so you can safely ignore it. So what rules you use, you should state in your solutions. You state in your solution what law you use. So all the quiz after the midterm will be very important because exam question will be very similar to the quiz. Similar. So you need to study your quiz well, and I will post up the quiz solution soon for you to revise. Okay. Make sure you look at the mark I allocate to the question again. So each mark should have at least one sentence. So you should know how long you should elaborate on the question. Second, we will have the relation. Again, what we do in the relation is equivalent relation, partial ordering, concept. Okay. So in the equivalence relation, we learn what's the definition of relation, reflexive, symmetric, and transitive. So relation, I want to remind you again, relation is not connection between two elements. Relation is a subset of Cartesian product. Okay? I want to remind you, relation is just a subset of Cartesian product. So if equivalence relation of X, the relation is a subset of X cross X. And you just need to give me a subset. And under partial ordering, what's partial ordering? So we swap symmetric to anti-symmetric. So what's the consequence of swapping this properties here? Is we can order the. That's why we have the Hassel diagram. And then we can figure out the maximum element, minimum element, upper bound, lower bound, greatest lower bound, lowest upper bound. Again, we can find all these elements, can compare them, and then from there, if we can order further, we can look at the totally ordering. If every element is comparable, then I think some of you quite good. You know that totally ordering is a chain, and then you say that in the quiz, you say if it's not a chain, it's not totally ordered. Okay, but they're not comparable. And then well ordering, and then lattice is in the exam as well. So similar to quiz question. Okay. So another thing I want to tell you is this divisibility, right? Divisibility, if I write something like Z divisibility, right? So this actually means Z plus. Okay. So we only do Z plus. So if you see a typo, straight away change it to Z plus. Okay. No need to ask me. But we only define divisibility of the positive integer. Okay, start from 1, 1, 2, 3, and so on. Okay, So we don't define something like -3 divide 3, and we don't have this. Okay. So I think there's two questions on relation. So make sure you know the examples of relation well. Okay. Two, I think two questions. One equivalence relation, one partial relation. Okay, graph and tree is a long topic. So at first we start with the locality property of the graph. We learn about the degree of vertex, and then neighborhood of vertex, adjacency matrix, decision matrix. Okay, and then we have this handshaking theorem that relates degree of vertex and the number of edges. And then the next thing is we learn the bipartite, how to split the vertex into two sets, okay, using the chromatic color. If you show that chromatic color is 2, you get color with 2 colors, then it is bipartite. And next we learn Euler path, Euler circuit, Hamilton path, Hamilton circuit. So Euler path is path that passes through every edges one. Hamilton is passes through every vertex once. Okay. So only Euler path and Euler circuit have definite answer that you can check from the degree of vertex. Okay. So to get Euler path, you need to have exactly 2 odd degree of vertex. Okay. So why these 2 odd degree of vertex? These are exactly the starting and ending point of your Euler path. Okay. So if your answer don't start or end with this vertex, straight away the Euler path is wrong. Okay, I don't need to check whether how you go through it. I mean, okay. So the Euler path must start with the odd degree vertex. Exactly these 2 odd degree vertex. Okay. Euler circuit, all vertex have to be even degree. So there's no for Hamilton circuit, there's only O's or direct Dirac theorem to check whether you have a Hamilton circuit or not based on the degree, but not very practical sometimes. I mean, most of them. The next part is planar graph, whether you can draw a graph without edge crossing. Okay, so we learn the Euler formula and then the 3 corollaries. So these 3 corollaries, right? If G is planar, then some inequalities is true. Okay, this one cannot apply backward. You cannot say if the inequality is true, then it is planar. Okay, there's only one direction here, only one direction. What you can use is if the inequality is not true, then it is not planar because this is the contra positive of the statement. Okay, only this you can use it. Okay, so in the exam, because these 3 corollary there's no name, so you can just use it. Okay, just say by corollary, think this is not true, then it is not planar. You can use like this. There's no name for this corollary. The next one is a homeomorphic graph, and then we learn the elementary subdivision, and then the Kuratowski theorem, how to check something is not planar. This is a definite check. So if you can find a subgraph that's homeomorphic to K5 or K33, then it is not planar. And then the next part is graph coloring. Okay. So what's the least number to use to color your graph? Chromatic color. Okay, to show the chromatic color is M, for example, you need to give me 2 arguments here. Okay, this one you need to know. I think it's in the exam. So first, you need to argue y is less than equal to M, and then you need to argue y is greater than equal to M. Only then you can conclude it is M. So y is less than equal to M. You need to first produce the graph color with M colors on it. Okay? Then the least number must be less than equal to this. Right? Because it's the least number to color it. And then to show that the chromatic color is greater or equal to M, usually because it contains a complete graph of Km, usually. Okay. So what does this mean? What are complete graph? For example, K3 is a triangle. Okay, so in triangle, every vertex are connected. So you need to have at least 3. How about K4? Every every 2 vertex are connected in K4, so you need to have at least 4. And then so on. Okay, so usually it's this method here. Depends on cases, but usually this is the argument. Okay. Next is tree. So trees, first we label the vertex. Okay, we tell the relation between different vertex. We have ancestor, descendant, parents, children, siblings, internal vertexes, and leaves. Okay, so this one definitely got exam. So in the exam. Okay. And then next is how to go through all the vertexes in the ordered rooted tree. Okay, so the tree traversal. So you need to know the universal address system, pre-order traversal, in-order traversal, post-order traversal. Okay, so for example, the pre-order traversal, you need to visit the root first, traverse the leftmost tree, and then traverse the right trees. So these three are just playing around with the order of visiting. Okay. And then trees next, the last part is the spanning tree. Okay, find the spanning tree for non-weighted one or weighted one. If non-weighted one, you have 2 methods, depth first or breadth first. Weighted one, you have primes and crucibles. I think not much thing I put on this section here. Maybe you can just read through. I forget, but I think I will have. Okay. Yeah. Okay. And I think that's all for the trees. Okay, for the Boolean's algebra, so we start with the abstract definition of Boolean algebra, and then we talk about Boolean function, and then we talk about minimization of Boolean function. So truth table will appear again in the guise of Boolean function. Okay? And then minimization of Boolean function, we have 2 ways. One is using the K-map, the other use the QM algorithm. So I get so the general principle is to find all the prime impedance first, and then determine this number smallest set of prime impedance to sum to the original function that can cover the original function. There's the last question is the K-map. You have to know how to do the K-map. Okay. Any question? Exclusion, inclusion, important or not? They will have question use that. Yeah. But I think will be clear from the context of question. You will know what to take away. In this time of exam, there's not much proof question. Just some question ask you to check maybe the definition, for example, reflexive arithmetic symmetry. Yeah, so there's no like proof to this question. That's straightforward, I think. Abstract definition. Abstract definition. Then we talk about what's Boolean function. Boolean function is a set with 5 operations that satisfy the 5 laws. So it is abstract because you just need to have one set that has 5 criteria and then 5 laws. It will automatically be Boolean algebra. For example, example of Boolean algebra is propositional logic, set theory, and then the lattice. These are the example of the Boolean algebra. So we abstract the properties of this example. Yeah, we abstract the property. So we just pick up what is their similarity. As long as we satisfy this law, then they are called non-different. And then they will share the same. Yeah, we prove one theorem that can be used in different areas. Any more questions? No? If not, you can one by one come here and collect your quiz. Then after you collect your quiz, we will discuss the quiz. Yeah, now. Yeah. You can come and collect one by one, collect your quiz. You can sign the attendance for the last time.
我帮我那个室友也找一下。室友？对的，在这里啊。对。
我也我们之前右边的。
改工。改。
那又拿着6题后悔。
说过完。好像是这个William 上第四个，对吧？我能噪音都很好啊，噪音有很好。每个人会有评价，很多人交不是交这些交表格，就不感觉你看那个。
哎，就没有很低。
没怎么说，我到哪里去都不到。是啊，因为我们
然后后面开始。
Edric 啊，Edric，
不是后面没有。
这个没问题，这个没问题，
没关系，
没问题。
外面有，还是个人解释过去，还是弄。
Casper 哪天你看哦，
哦，对啊，没错，应该是弄了那个工作，有必须看的。一个，一个，快点，
哦，你没有换那个 p a 哦，
你要放两，
换那个 p a 出来，
这边
哦，我的 p a
哦，不是，
要换了，
因为很多对嘛，他不是二十四小时回头看，
对对对，
螺丝这个不能命 VQSD true。
不可以，等下我会解释。
哦，OK，
其实它不是 Vegas，
反正有人就是可以走过去，可以，
它有一条线，
有两个点可以看见，一个没有，它是一个起，它是一个点，然后一个中嘛，它的中间其实不一样的，
它是可以设改的，
高的，
可以设改的。
一样的，这一块是在穿，
等一下，现在好。 你拿吗？你叫什么啊？姓什么？AIANG？哪一个字？啊，错明细，我有那个。
Everyone got the quick yet? Yeah. The quiz. So, first one, yeah, first two thing is this Z plus and Euler path. So, divisibility only define on Z plus. So, whenever you see Z, just change it to Z plus. It's a typo. And Euler path, there are two ways to show it. Either you draw one non-stop path, or you give the vertex. Again, so don't just put arrow on your graph, because there's some ambiguity. I don't know where to go. Alright, for example, if I reach D, should I go A or should I go C first? Okay. So sometimes there's ambiguity. So you can draw a non-stop path, or you just show me the text. Okay, so that I can follow the path. The next question, actually, I wanted to put the hint prime factorization theorem, but I forgot. But never mind, since everyone got rid of this hint. So I will explain why this theorem will be useful to answer this question here later soon. So the first part is explain why the divisibility on Z plus is anti-symmetric. So it is anti-symmetric because for every A and B, if A divide B and B divide A equal to B. Okay, this is the answer I gave in the lecture note. So I just explained why, so you don't need to prove why this is true, okay? So why a lot of you say that this statement is recklessly true? Actually, it's not, because there are numbers that satisfy these two conditions. For example, 1, 1, 2, 2, 3, 3, 4, 4, okay? So these numbers are all A divide B, B divide A. Okay, so this only happens when A is equal to B. Okay, so there are cases. Okay, not recklessly true. Okay. Okay. Next. So drawing this Hessel diagram, right? So if you know their prime factorization, it will be come in handy. Okay. So what is the similarity of the number here? They are actually product of 2 or product of 3. Okay. So when I set this question here, so I just put 2 and 3, and then one number 8 is only divisible by 2. The other number is divisible by 3. And then I want to make sure that 12 and 18 are divisible by both of them. So I put one factor of 3 on 12 and then factor of 2 in 18. Okay. And then what is 216 is actually the LCM of this second level here. Okay. So I put all the factor in the LCM. So this is how I build my Hessel diagram. Okay. Some of you are still drawing horizontal line in the Hessel diagram. Okay, this doesn't work. So every relation is going down to up. And then some of you draw upside down. Okay, you draw from 1 then to 1216. This one is different convention. Okay, draw from bottom to up. Bottom to up, not up to down. Bottom to up. Okay, this is our convention. And no horizontal line. No horizontal line. This. Okay. every arrow, every line is going up. Okay. That's why we remove the arrow, because we know that every line is going up. No horizontal line. Okay. No relation in poset is equal. Okay. 1.3, 1.3, find the maximum element, and then is there a greatest element? Okay, I think a lot of you did it correctly, and then yes, there's the greatest element. Some of you just put yes, I also give you mark. So usually you need to tell me also which one is greatest. I think this is the way how the textbook asks. So also follow the textbook. You also need to give the what's the greatest element, okay? To say that you have the greatest element. 1.4, determine whether it's a totally ordered set or not. No, because you can find two elements that are not comparable. Okay. Just give me any two that are not comparable. And then find all the upper bounds of 2, 3. I think a lot of you did it well. You got it. Determine whether the poset is a lattice or not. No, because I already set 1.5, ask you to find the upper bound. I just don't ask you to find the least upper bound. So if you try to find the least upper bound, you cannot find it. Okay. So it's not. So in this kind of question, right? I think a lot of you trap inside the question. So meaning, for example, for lattice, every pair have to have least upper bound and greatest lower bound. So you go and check every pair, okay? Check one by one. So actually, this kind of question, there's a quick way to see it. So either you quickly find something is wrong, or you there's an easy way to check all of them. Okay, so you don't need to like check slowly one by one. There should be a fast, quick way to see it. Okay, to check something is totally ordered or to check something is not like this. There should be a quick way to see it. Okay, you shouldn't dive in yourself and looking for one by one. Okay. I think you guys did better. I think few of you get quite a good marks. Jiao, we got 10. Chen King also got 10. Nanning also got 10. Joshua even got 9. Ji Chenhao is good. Who is Ji Chenhao? Ji Chenhao. Oh, Ji Chenhao got 10. Liu Yuqian is good. Liu Yuqian. Liu Yuqian is Liu Yuqian here? No. Liu Yuqian got 9. Liu Yunhao. Liu Yunhao. Liu Yunhao not here. 10. Luo Yijie. Hey, Luo Yijie, quite steady in this class. Oh. Can I ask you how you study this course? Can you share how you study the course? Practice? How you practice? You do all the tutorial question or what? Okay. Okay. Yeah, he quite steady. Every time go quite high, either 9 or 10. Okay. 徐念和 okay. 张子瑜 who is 张子瑜? Okay, got 9. And then Ong Wen Jen. Ong Wen Jen is the single person that get full marks. Like every section, even my bonus also he score. 3 classes. Yeah. Yeah, he score all. So got. Very good. Can see some of you improve this time, so keep improving. Okay. Next is the graph. Okay, so we take the Hessel diagram from the previous question and then answer the graph question in this question. So maybe some of you say, if I cannot answer the Hassel diagram how? Okay, there's one student, okay, he don't have Hassel diagram. So he put down the definition of Euler path, Euler circuit, bipartite, or planar. I also give mark. Okay, this means you know how to find. This you don't have. So I also give mark. Okay, so just try everything you can in the example. So from the Hassel diagram, we can disregard the vertex and then we see it as a vertex and edge set. So it's a graph. So whether it's a bipartite or not, okay, some of you give me two partition, okay, works. If this one buy too much time, you just color it. Color it. If you can use two color, it is bipartite. Okay. 2.2. So whether it's the Euler circuit or Euler path, so you see here, this is 4 marks. Okay, you should know my style already. 4 marks need to have 4 sentences. Okay, so Euler circuit 1 sentence, reason 1 sentence, Euler path 1 sentence, reason 1 sentence. Okay, so construct the path can be the proof of the existence of the path. Okay, so this counts as a reason. No Euler circuit because not every vertex have even degree. As the Euler path because exactly 2 is the Euler path. Next question is the most interesting one, whether this graph is planar or not. Okay, this is the starting point of my quiz, how I design this quiz. So I start with designing whether it's a planar or non-planar. Okay, so actually I also start myself quite a bit of time in this question. So I thought this graph is non-planar, but I cannot find K5 here. Okay, some of you say I can find K5 inside here. You didn't really go and find it. So actually, if you go and find K5, you cannot find K5 inside there. So that means this graph should be planar. Okay, so how is it planar? So you can take either 12 or 18. Take this. Yeah. So you can take the 18, okay, and then take this 18, move it up. Okay, once you move it up, then you can form a non-planar graph. So a lot of you straight away see that, oh, there is edge crossing, it is non-planar. But if you can produce an isomorphic graph which has no edge crossing, it will be planar because it admits a planar representation. Okay. If you want to show something it's not planar, you have to try all the way that you cannot draw a graph without an edge crossing. Okay. In this case, you just move the 18 on the 12th vertex down. The number 18. Okay. What's the chromatic number of the graph? Okay, so if you know how to check bipartite using chromatic number, then this question is just a bonus mark for you. So the chromatic number of the graph is 2 because it is bipartite. Okay, you don't need to show less than equal to 2, greater equal to 2, because in the class we already say that the chromatic color of bipartite graph is always 2. And this is how we determine the graph color. Make sense? Yeah, this is a special case of chromatic color equal to 2. So bonus mark. So bonus mark, I ask you to draw a graph that's not isomorphic but homeomorphic to the graph. Okay. So homeomorphic, you just do elementary subdivision. Okay. So non-isomorphic, so that means the number of vertex might be different, or the connection of how you connect the X different. Okay. So you cannot draw an identity graph for me, because if you draw the same graph, it is isomorphic because it's the identity. Okay. So what you can do is you just add extra vertex to any edge. Okay. So this is done by elementary subdivision. Okay. Also, you can remove graph, remove edge. You no, remove vertex. You only can remove vertex when their degree is 2. Okay. So for example, what you can do like this. Okay, this is homeomorphic as well. You can remove edges. You can remove vertex, or you can add vertex. Okay, homeomorphic. And then what's the Euler characteristic of the planar graph? So this one you cannot find in the textbook. You only can find in my lecture notes. So I talk about this, the last part of the planar graph, Euler formula. Okay. So the Euler characteristic is 2 as well. It's the 2 appear inside the Euler formula. R equals to E minus B plus 2. 2 is the Euler. So I think a lot of you, right? Something like it's planar, something happened. So you thought that there are the characteristic of a, I don't know, Euler graph or Euler path or Euler circuit. Yeah. Okay. So this is just extra mark. So not in the normal content, but got it, then you will have a bonus. Okay. Any question? Yeah, I'm not sure why a graph generally not so good. Is it like short time? Short time, haven't do revision yet. Generally low mark in graph.江小艺是吧？江小艺，会江小艺啊，OK，江小艺，江小艺 got 10 in graph. Jia will also got 10 in graph. Dexter. Okay. You know, question. If you have done the review question, we also can discuss inside the class. Review question. Okay. What question is there? Let me bring it up. 9. Yeah. Sub 2. 9 sub 2. Okay, 9 sub 2. Let's see. 9 sub 2. Sub. Nine sub 2. Okay, 9 sub. This one, yes, this one. This one for the A. Right. No. You have to start with the set here. Yeah, start with set. Also cannot like subset form. Not a simply relation. Yeah, this one is a relation on a set. So you need to consider the subset of maybe call it X. X cross X. Okay, so you need to pick a subset. You get what I mean? So your relation is something like A, B, BC, something like that. Okay, and then check the relation you give is reflexive or not, symmetric or not, but not symmetric. And yeah, this kind of question is in Need to construct relation. Know how to construct relation. Okay.
So technical.
Huh?
Technical.
What do you mean technical?
The question is
22? This one 22. Huh? Yeah, okay. You know how to show is
one.
1 half and pi. Huh? Okay, so this is the equivalent class notation. Okay, so what are inside the equivalent class of 1? Okay, as long as okay, so what's the definition of the equivalent class? Equivalence class. Equivalent class. So all the elements that are related to related to the element. Okay, related to the we call this the representative. Okay, they are related to the representative. Okay, so how you relate two elements in this case? What's the relation? You need to take the reference, take the difference, and then show it that it is in the rational. So what is so what number minus 1 is in the rational? Huh? 2. Yeah, everything. Actually all the rational numbers. Because rational minus rational is giving rational. So similarly for the equivalent class of half. Okay, actually these two are the same equivalent class. Okay, because they contain the whole Q. Actually it's equal to Q, these two sets. Okay. But pi is irrational. Okay. Pi is irrational. So what number minus pi is in the rational? Okay, pi is one of them because pi is the representative, right? Pi minus pi is 0. Okay, who else? It's a q minus pi. Yeah, something minus pi or plus pi. Depend on right, because if you take pi, if you take pi minus rational plus pi, you get the rational again, right? And then q plus pi minus pi, you also get. I mean q meaning any number. Right? Mm. Everyone signed already? Everyone not signed yet? I haven't signed. Pass. Emo? And I think relation one quite related to exam. But the rest is just to the quiz question will be very crucial. Quiz question, tutorial question, if you do, I think you can get 80. If you can do the quiz question, you can do the tutorial question. Yeah. Very, very. Very nice. Chapter 6. Uh-huh. Oh, okay. Uh-huh. Yeah. How about that? Yeah. Uh-huh. Yeah. So the question is like you cannot do that. Just cannot do that. So you cannot do that. Mm. Yeah. It's not enough object to choose. Yeah, I just realized this yesterday someone asked me also. I just realized about this. Not stupid, but uh, I think there's that question, right? The part D is hard. The part D, we didn't teach in this course. Actually, in my university, they teach it. It's called the star and bars. Maybe you guys will touch it in computer, I think. I don't know. Already done it. Star and bars. Huh? Something like that. I mean, combinatorial problem. Star and bars. Yeah. The supplementary 2D is a star and bars problem. Okay. If you don't know, also never mind. Let's skip that. Not as that kind of. Star and bars. Okay. Any more? Okay. For the rest. For the rest. For the rest. For the rest. Any? No more. One last chance. Any more? Last call. Last bid. Any more bid? No bid. One. No more. If no more, so thanks for the semester. Good luck in your final, and then I'll see you when I see you again. Okay, please return. Please, I'll tell you. The characteristic of whatever is that for thought, you mean the characteristic in can you explain what the first sentence? Oh. So what's the meaning? Why? I don't do anything. Okay. No, no, no.
It's fine. It's
No, no, I want to tell you that there's no. I also don't know what you said. I don't know what you said.
No. I think that
So Eric can please think this. Good morning.等下我注意一下，等下问题。OK，拜，有缘再见。一定有缘再见。我们考试还没再见。OK，先讲这个，这样应该有分。我那个，这个。哎，你要咖啡，你要咖啡，你泡了吗？我讲他这个泡。哦，但是你要泡是脱的吗？没有。哦，我知道了。没有上过。我真的可以。对啊，先 OK， 你先看这篇。我先弄吧。
全部都是第一个很倒的，第二个没有。
怎么你？也是你？
哦，这个人是，可是这个没对哦。
我第二，我对面是一本上来，但是有一个一本的。
我这个。
第二个对了，我只看到一本。对。
我今天少花，
我那放一本。开玩笑，你哪里的话？哪里学的这话？一本。
我学徒。
这两个是对的，
那没事了。
因为你这个图的问题，你这个图其实是个 lattice。
哦，因为我这个图，所以我
对，
我这个图还能算画对面，因为其实3要点到12。
我至少我给 level 对的人都有一分的，至少 level 对。
所以你会给我分数，是因为背诵我这个关系啊？
不可能，你看这个图，你给我这个图的答案，那个更厉害那个。
所以这样子也可以，你这样仁慈啊？
不是仁慈啊，这个是
你会看，证明你会看掉，你都是不会看我。
呀，
你会本的。
对呀，重点呀，每一题的重点是不一样的嘛。这个如果你是黑到的话，我这样我也没有话讲啊。至少你还会写 definition。
你这样我嘛很 lucky 咩？我觉得 lucky 哦。看这里又可以，你又可以给我加。
给他加，不要给我加。
聊不来，想要对吗？有点心机，
又要给我加，
我真的是。
给他加。
纸上说不要，真实的真实的。
可能周都很想要哎，
周都很想要。
你都不加，变成好，我没有对，我给你分一个一分。
844。
没有扣，就对了。因为我的图是画成这样，所以他背诵我的图给我。
可你下次你这个 graph 要画好，
讲哎，
就是你要开始，你不要把它连在一起，你就从这边，这样我才知道这边可以。
就不要点到这一个点啊。哦 ，OK。
不可以，哪里数据就画好了。
你可以放 ABC 也可以，但是你也可以
彩笔。
不用彩笔，你就把它画大，你就把你的 graph 画大一点，然后你把你的 part 画在旁边就可以了。看得这样子啊，哎，这样子我就看得到了。
不要我的考卷。
那边几分了？对吧？我操，好高。
啊？不可以，我不跟你讲了，
但我很 lucky 啊，
我不跟你讲，它不符合才可以用这个
符合不能
符合不能呢
对，这个是
One Direction 啊，对，我刚才已经讲了，
哇，
那个方向是一个方向，没有时间 try 哈。
你一会我就看出来，为什么这个不行？
哪个？
我这里不合第三，
因为
是 remove 不可以 remove 这个，因为这个不是 elementary subdivision 出来的，这个有3个 elementary subdivision 是一条线切一半，它不是这个东西不
不，
，yeah 啊，不可以随便 remove，对，
我在这里加个点，其实都是很
对，
哦，
没有错，随便加一个点都可以啊，yeah，其实是很
所以它
没有很难的。
为什么不能用这种证
因为它的那个证明就一个方向吧，if planner then 那个没有符合了它 planner 没有这个反方向啊，对，
请问那个 anti-symmetric 能给个例子吗？又忘了，好容易。
比如说
来一个形象一点的例子，
形象一点的例子，
爸爸妈妈和我可以弄。
这样给他们解决完这 quiz 是这样，
第4分了，
什么
我记得我看不懂。
two
他的3没有连到12啊，
exactly two 哦，
他没有连到12，有吧？
你没有给我 path，我是扣你 path 的分，
我是背懂的，
你的 path 在哪里？
他考我的东西，
真是
因为我这里
我是靠你的 path 啊，我是扣你的 path 在哪里？我扣你的 path，我找不到 path。这个啊，这个啊，从哪里开始？从哪里开始？怎么？哦，对了，你要告诉我从哪里开始啊？
因为我不知道，
对，
会来看我。
背手你的那个 graph，哎，这里才有解释才有。
没有你的 graph，你的 graph，没说你的 graph，还是4分哈。Euler characteristic，Euler circuit 1分 ，reason 1分 ，Euler path 1分，path construct
那刚才你都没有，你3都没有连到
我以为是
所以
需要加解释，然后再狂刷就是。
需要解释。
对啊，我就没有
那你会选择题，然后
通常我1分是1句的，所以100分你要写100句东西。
那个没有写2分变掉，哇！
我懂没有，可是我没有写下去。
对，你要写。现在吗？现在啊。等下 ，OK， 最后这里哪里什么？
对，我这边写错，可是我这边有画出来一点。
可是我就不知道你从哪里
从
开始。
C 开始，然后
你现在讲有用吗？你现在讲有用吗？可是你这整个东西不是趴来了，你这么写出来，还没不是一个少写吧？是少写咩？
少写一个，
我是少写啊，
我这边开始
你少写？
写错了，
哦，少写啊？
就是我画错了，
为什么你少写？
因为时间太短。对啊，太赶了这个。可以重复经过一遍，
对，哎，总共给我点。
重复经过点。
对，好，少说一个点啊。
用很多，
这样我先问你，你知道有没有 Euler circuit？
没有啊？
为什么？
为什么？我的手机啊。不是每一个都是那个叫一问degree，
所以呢？
所以就没有 circuit 啊。
为什么问你？
因为不是每个文都是一问degree。
为什么？为什么不是每一个？不是这个例子，为什么不是？
2个有degree。
你只是忘记写出来。
对呀，我就没有写的，因为我以为不用写，我以为2选1，所以我就没有写出来。
OK 了，我那个2个半分我给你1分了，你这个可能真的是漏，你是真的漏写。
对，都写，我这边画出
加你
来。
1分呢，就半分给你啊。
我现场画出来也是加1分。
不可以。下次要全部写出来。
是你小学期上课吗？
是你在区
上课
哪一节？是
线性代数，
是 business 还是？
不是 linear
这个
algebra。
不难。我是说，是它的类型是 business 还是 art？
这我也不知道哎，你可以去搜一下 linear algebra，
哎呦天哪，你
它是局。
好可怕！
我记错你的分了，我这个3节还
我姐在国内学习代数全都涂掉了。
所以这不能的，可是我写出来
那个 planner，跟你讲这个不能够证明 planner 了哦。刚才不是跟你呢？对啊，我跟他解释了，
所以一定要证明这个才会。
一定要画得出那个 planner。这个不能够证明，你知道吗？
可以
为什么？
啊，
为什么不能证明？
你讲一
啊，建议方向罢了。
对，那才能
对，
打一个
还有
通俗易懂的例子。
anti-symmetry，
嗯，
anti-symmetry 的例子。
是 A 跟 B 是 relation，B 跟 A 是 relation，A 要等于 B。那如果放到现实的例子，
现实啊，你想现实什么现实？还是你要 set 个例子，还是你要什么？
可以打一个例子，我现在有点无法理解。那但如果他都等了，为什么不是
那
relation？
例子就是例